So this is section 3.3, part 3, and it's on independent events. And what I wanted to do is I wanted to now talk about this concept. So what we've done now is we've talked about some of the basic building blocks of probability. Now what we're going to do is we're going to talk about, well, when I talk about specific kinds of events, right? One, how do I prove that they're specific kinds of events? And then what does it mean to have these kinds of events? So now in this case, right, what we're looking at is we've got, a concept that we're going to use of conditional probability and our standard probability. So if you haven't looked at those and haven't kind of like got a good grasp of those, you're probably going to want to go back and look at those videos because you're going to need both of those. You're going to need conditional probability and our standard kind of probability. Okay? And they're going to play a role in understanding what it means to be independent. Now, what it is we'll ask ourselves, are these two events, A and B, independent? Right? And then what we have to do is we have to do a little bit of calculation, okay, and probability work in order to then prove that they are in fact independent, okay. And then we want to talk about what does that mean, because it ends up being a very important thing for when we do other kinds of mathematics, right, and when we do hypothesis testing in particular. So let's talk about what it means to be independent. So two events are independent if knowledge that the first event occurred does not change the probability that the second event occurred. So in other words, if the probability of the second event occurring does not change given the fact that the first event, the first event occurred, the events are said to be independent. So we often think of this as the first event having no association or effect on the second event. If the first event actually has an effect on the second event, then what we say is that they are in fact dependent. Now we have a mathematical way of actually writing this, because we want to be able to use probability in order to show that two events are independent. So here's what we do mathematically as a definition. Two events are independent if the probability of the probability of B is going to equal the probability of B given A. So if we know the condition, right? So here's the conditional probability where we know that event A occurred. If that probability is exactly the same as probability B, then what we say is that these two events are independent. On the other hand, if the probability of B does not equal, okay, so these two are not the same, the probability that B given A, then what we say is that the two events are dependent, okay? So independent means that those two probabilities are the same. Dependent means that they actually are different. So what we're basically saying down here with this probability statement is we're saying that if I know that A has occurred, then that actually tells me that it changes whether or not I think B is going to occur. And you'll see that this is going to end up being really handy. I give an example, for example, of smoking and lung cancer. So if you knew that the person that you were talking to, right, had been a smoker for 20 years, would that change whether or not you think that they got lung cancer or that they were going to get lung cancer? Would that change your feeling about the probability that they would get lung cancer? So let me state that again. If you were talking to somebody, right, okay, would knowing that they were a smoker change the probability, okay, that they would get lung cancer? And the answer is yes, because you know that smoking and lung cancer are what we call associated, that smoking causes lung cancer. And so consequently, you'd say, well, you know what? Because I know you're a smoker, I now think that you have a higher likelihood of getting cancer. And that's kind of the idea that we're working with when we do probability, when we do independence and dependence. Those two events are said to be dependent, right? Smoking and lung cancer are dependent. Let's take a look at one in which we use some data. So suppose that we had our data set about males and females and their shopping habits. So what we've got here is we've got a grouping for males and females, and we have whether or not they like shopping or do not like shopping. Okay, and then we have their totals. So we're going to say, okay, the probability that an individual likes shopping is, we add these two together because that's all the people who like shopping. So that's 34, okay, out of 50. which is 0.68. I think that's slightly different from what we had in the previous one, but we'll use these numbers today. So that's 0.68. Now, what about the probability that an individual likes shopping? And the condition we're going to do is we're going to condition it with a gender, given that they're male. So now we're asking ourselves, if I know that the person that I'm choosing randomly is a male, is that going to change whether or not I think that they are going to like shopping? All right. And our intuitive sense is probably yes. Women have a tendency to like shopping more than men. This is the way it is. And let's look at our data, though, because it's actually going to tell us. The number of men who like shopping now is 12. And the total number of men is 23. So 12 out of 23 is equal to 0.522. And there it is. So 0.522. Now notice that the probability that an individual likes shopping does not equal the probability that an individual likes shopping given that they are male. Those two are not equal, and so what we say is the two events are dependent. So let's kind of review this and we'll kind of summarize it. Okay? Actually, allow me to. What we've done is we found probabilistic proof. The proof is here. I found the calculation for the probability that somebody liked shopping. I found the calculation that somebody liked shopping given that they were male. So I put a condition to it, okay, one of our gender conditions, and saw whether or not the two are equal. That comparison tells me that they are not equal, so consequently, these are dependent. Okay? So, like I said, let's take a look at just a rundown of these events. One, right? How do we find they're independent or dependent? Find, right, the probability of event B without the condition. Two, find the probability of event B with the condition of A. Three, compare those two probabilities. If the probability of probability of B equals the probability of B given A, then the two events are independent. If, on the other hand, the probability of B does not equal the probability of B given A, then the two events are dependent. Okay, so what does that mean? Well, let's talk. So basically, that's how we find whether or not something's independent or dependent. Allow me to give you some tips and tricks. Okay, determine which is event A and which is event B first. And then actually write them down. And the reason why we want to do this is because the order in which we do the conditional probability and the probability are really important. Make sure that the order that you do the condition, right, is the same as the one that you did without the condition. So the first one, or what we consider actually our second event, right, is not the given. All right, so the value here is not going to be the given. All right, that's very important. Notice where B and A are. It matters. If you remember when we were doing conditional probability, if you change B and A to A given B, you actually get a different probability most of the time. So consequently, You want to make sure that you actually get them in the right order. Okay? So that's the first thing. And then the second thing is make sure that when you're doing your conditional probabilities and you apply the condition, that you're only looking at those things that have the condition. So those are two areas where when we're doing independence and dependence, there are a lot of people make some errors or mistakes. Okay? So I'll repeat that. Make sure that when we have this probability and we have B, that's the likes one or whatever is our second event, that we keep that as the initial event and not the condition. The condition is the other event. Okay? This completes the video.